Hi, Mike Amundsen here, and I want to discuss the idea of a unified API design method in a talk that I call GraphQL, gRPC, and REST, oh my. The title is actually referencing a movie, the 1939 movie, The Wizard of Oz, when the main characters end up in this really scary forest and they realize that it's full of tigers and lions and bears. Oh my, and they keep repeating that over and over again. And I realized this idea of talking about API design and unifying various points of view might be a little bit like walking through the dangerous forest. It's another great scene I like in the movie where basically they run into a sign that says, "I'd turn back if I were you." And maybe others would turn back, but we're going to press ahead and we're going to talk about this idea of API design and unifying things like GraphQL and gRPC and REST and streaming and all sorts of things together. So first of all, this is me. This is how you're going to find me on LinkedIn and GitHub and Twitter and YouTube. I would love to connect with you, find out what you're working on and what's interesting to you. Please get in touch with me and join me for lots and lots of additional content after this. Now, the material I'm going to be covering is actually from a book that I'm just completing now called Design and Build Great Web APIs with Pragmatic Publishers. So if you like what you see here or you're intrigued about some of the ideas, you'll find much more detail in this book. So really, I want to talk about a couple of things. I want to talk a little bit about a story of design and governance. This is a story that I've seen played out over and over and over again. You might recognize yourself in this story. Then I want to drill into the challenge of HTTP-centric API design and why that is such a challenge and causes problems. And then I want to come up with at least one idea on how we can get past this challenge, and it's what I call the unified method for API design. So let's enjoy a little bit of a story here. Now, you might recognize yourself in this story. You might recognize a company in this story. This is taken from a collection of all sorts of things that I've experienced over the last several years. So let's say it's a large company and they're committed to a strong API design practice. They know they want consistency in order to scale up their API community, and they've made a design a responsibility of a central enterprise body. We're going to do this right, and we're going to do this right through the whole company. After research, they've determined that OpenAPI is the great backbone of their practice. They've got common usage, lots of general guidance available. So they've mapped out a holistic approach to API design and made OpenAPI a key foundation in this whole process. This is a really powerful definition language for HTTPIs. So they create courses, they write guidance documents, they build their own custom editors or linters or catalog systems. I've seen all of these kinds of things happen. They hire and train full-time design review teams to promulgate this practice and make sure everybody's doing it the same way. And they gain this level of consistency in their organization. Well, everything is going fine until they want to start using something like GraphQL or gRPC or even update their SOAP services from SOA days. It turns out none of their training, their tools, or their processes apply anymore to these different technologies. They've actually landed on a very HTTP-specific way to do design and governance. Now, in order to get this going, they're going to have to add training tools, review teams, all these other things in parallel processes. So the way we do it in GraphQL is this, and here's our review team, and here's our tools. The way we do it with streaming is this, and here's our Protobuff, and here's our review process, and so on and so forth. And this gets massively expensive, and it doesn't scale well because it means each new style or technology means an entirely different process track and a whole stack of additional tools. So what's really going on? What's really happened? What's happened is we've run into the challenge of HTTP-centric design. And there are lots of reasons for this. Most of them are very innocent. Some of them are actually very good reasons that we've run into this challenge. So it turns out that HTTP reigns supreme in most organizations because most of us started with HTTP-based APIs. There's tons of tooling. There's lots of training that focus on this HTTP world. So naturally, we think that's where we start. The problem is leading with HTTP means when all you have is a hammer, everything looks like a nail. The HTTP elements themselves turn into being design elements. So we design URIs. We talk about how to use methods. We design headers and resource bodies and status codes and all these other things. And we become completely immersed in this HTTP-centric world. And that means things like OpenAPI, which is very HTTP specific, becomes troublesome when we want to get beyond HTTP land. AsyncAPI, Protobuff, Schema Definition, SOAP, these are all parallels to OpenAPI. Not competitors, but parallels. They're the same kinds of things, but in different spaces. So it turns out that when we keep defining things through an OpenAPI, we keep trying to define things through HTTP. That's the governance we create. And we end up creating this sort of gatekeeper system where you need an OpenAPI definition in order to get into the company catalog, in order to get past review, in order to get credit for creating your API. Now that means you have to duplicate governance for all these other stacks as well. And when you have to duplicate it for GraphQL and duplicate it for async APIs and so on and so forth, suddenly that becomes a huge expense and everything's broken and people get annoyed. And especially in an enterprise environment, this is considered a huge failure. It's not really, but it's considered a huge failure. What it really does is it slows experimentation, exploration, and rollout of innovative solutions because I've got this hurdle that I've got to cross, and that hurdle is HTTP. So how do we solve this problem? Where do we go with this? What do we need to do that's different? And what I say we need to be doing is thinking about a unified method for design that's divorced from a particular technology, whether it's GraphQL or AsyncAPI or HTTP CRUD or REST or anything like that. So we need a generalized solution. We need to think about it differently. We need to use design methods that don't rely on HTTP specifics. We don't start with the CRUD routine or resource-based designs. We don't spend our time designing URLs or headers or status codes or methods. We need to think of this in a different kind of way. And that means we need to focus on the interface itself. And the interface has just a few properties. It has these individual data elements and it has actions. So we need to define the data properties, give a name, SMS number. We create a catalog, a collection, a language for an API, not objects. We don't need to define customers or documents or persons or contacts or products or anything like that. We need individual data elements, just like we would create in a dictionary. And then we need to define actions, that input, transform, output experience. We don't need HTTP resources that have methods on them. We don't say post to the customer URL. We need to say, I need to update a customer. And that's going to be much more universal when we move to something like gRPC or we create something in GraphQL. So that means we've got to document this in some kind of generalized way. And that means using an interface description language, not a definition language, but a description language for our designs. There have been a couple around for quite a long time. The Dublin Core Application Profiles, or DCAP, have been around for over 15 years. And the application level profile semantic, which is something I and a few of my colleagues put together, has been around for more than 5 years. ALPS, for example, is used by a lot of the Spring tools to do the same level of describing the language of the API in general terms. Once we know how to do that, and I'll show you an example of that in a little bit, that means that we can translate our designs into implementation-specific elements. I can translate an ALPS design into OpenAPI specification, into AsyncAPI specification, into prototype, protobuffs and SDLs and so on and so forth. So what we want to do is we want to start with a unified base. We want to describe things in an interface property and action way using a consistent language that can then be implemented in various ways. And that implementation can be decided by developers, not by designers. So let's take a look at some examples of this to show you exactly how this ALPS to translation works. First of all, since we're doing design on an API, let's start from a design document. This is actually the document that was written for a simple to-do list. It boils down to needing just a couple of data points, the ID, which is going to be unique, and the body, which is the text of the to-do record, and some simple actions, list, add, and remove. We'll keep it super simple for this kind of demo. So once we've decided on this, we need to turn this into some machine-readable format, some standardized design document, and that's where the ALPS document comes into play. So what does an ALPS document look like, and how is it different from other documents? So this is actually the ALPS document for our example, our to-do list. And it's fairly simple. It's fairly straightforward. It's our simple to-do list. It's got some metadata in the beginning, the name, the unique ID, maybe the root starting point if you're running a mock service or something like that. Everything in ALPS is called a descriptor. It describes something. It describes the data. It describes an action in some kind of way. So we have some pretty simple descriptors here. We only have a couple of properties that we need to deal with. We already know from our documentation that we need an ID property and we need a body property. And in ALPS, these data properties are called semantic descriptors. They describe the meaning of something. So it has a meaning. ID has a meaning. Body has a meaning. There's also something in ALPS that are called groupings. Groupings are what you might think of as objects or classes or resources. It actually says there's a thing called a to-do item, and it is a group of some properties, some of these semantic elements, in this case, an ID and or body. There's nothing here about strong typing. There's nothing here about what's nullable or what's required or optional or anything like that. This is really just the interface description. All those other details will be handled in the implementation, either at runtime or design time. But then there are actions. Actions are the things that we're going to be able to do. People don't really care about your data. They care about what you can do with it. So we're going to be able to list, add, and remove. And you'll notice that each one of these actions are marked with a type. That this is it's a save type. That means it's a read type. It means it can be repeated over and over again. An unsaved type is a write that can't be repeated. Think about monotonic data value for inserts, right? Every time you insert, it gives you a new record. Or you can think of an idempotent action. Idempotent actions are write actions, but they can safely be repeated. I can try to delete record 17 as much as I want. I'm only going to delete the record that's named record 17, so I can repeat that. So that's really what a descriptor, ALPS descriptor document is all about: the actions, the groupings, and the properties. So how can these be turned into implementation-specific elements? Let's take a look at how we would do that. For that, we're going to use a little utility. First of all, I'm just going to show you that I only have one thing here. I just have this one document that we talked about here earlier. It's the same document that we were just looking at a second ago, the actions, groupings, and properties. So what I also have installed is a little utility called Unified. And Unified is a utility that lets us input one of these profile documents, these ALPS documents, and output other kinds of definition documents like prototype or STL or OpenAPI or something like that. And that's just exactly what we're going to do. We're going to take this document here and we're going to say take in the file of to do, and we're going to output, schema definition language, right? So this actually reads the document and then outputs a valid schema definition language document. There's my to-do item type, my query setup, and my mutations for add and remove, and a little cleanup on the query side. So that's actually a valid schema language. It's not really a very entertaining or creative one, but it is valid. So I can also do the same thing for Protobuff, right? So if I want to generate a Protobuff record, I get the same idea. I get my parameters, my to-do item, my response, and then here's my RPC service list about to-do list and add and remove with the input arguments and the output arguments. Again, all contained from the very same ALPS document. Finally, one that's a little bit more involved, a little bit more to it, is the OpenAPI document. We'll show the OpenAPI document. Now that is a bit longer, right? It's got servers, it's got paths, it's got responses, 200 codes. It knows about post and delete and get and all these other things, and arguments and schemas, and even example strings for your property types. So that's really how we put all those things together. And we can actually see how these validate out as well when we take a look at this. So this is actually what happens when I load this simple to do into Swagger. I get the full documentation. I can actually even run mocks, generate SDKs, and so on and so forth. For my GraphQL editor, I have all of the analysis of what the mutations are in the queries and so on and so forth. And even for my proto files, I actually can load these into a tool that will generate the code for C# or C++ or VB or Java or something else like that. All of these coming from the same starting point. And that starting point is this really straightforward ALPS document, which is really a descriptor for the interface. It's a description language rather than a definition language. So now that we've seen some examples of how we can do this, we get this notion of what a unified design method is really about. It's really about starting from a general base and moving to specific implementations based on developer needs. So let's just talk about this whole idea a little bit and kind of wrap this up. So what we really want to do to get this unified API design is break the HTTP-centric grip on your current processes. So stop using URLs or methods or resources or status codes as design elements. You still need to use them as implementation details, but not as design elements. Instead, what you want to do is interface description language. You want to embrace this idea. You want to stick to using properties and actions to describe your APIs. This is the action you're taking. These are the arguments you can send in. These are the outputs you're going to get back. By focusing on those particular elements, you'll create a generalized kind of design language that everyone in your organization can use no matter what technology they're focused on. So then you want to enable those translations from your description language to your definition language. You want to translate those design documents into implementation-specific definitions. This means AsyncAPI, SDL, Protobuff, OpenAPI, even things that we can't even think of today are going to be possible if we build this translation idea, starting from a general design, moving to that implementation-specific detail. So even if you only use one API style today, maybe you're basically still using REST and CRUD, and that's just fine. You can prepare for supporting others in the future by teaching your teams to start using this interface description idea. It also frees things up. In a lot of ways, you can describe things in a much more general way for a much wider audience. I don't need to understand HTTP in order to understand your design description. I only need to understand HTTP if it's important to my implementation detail. So future-proof your designs, enable translations, embrace the interface, and break that HTTP-centric grip on your current APIs. And that's really all there is to it. And like anything else, you can do this in a step-by-step, incremental sort of way. You don't have to go all in one day. You can start experimenting today. Start looking at the tools, start looking at the options, and see what you can find. Now, I'll include the slides. You'll get a chance to take a look at these, but you can find more about this in my book. You'll find all the talks and slides and examples online. And if you're interested in this, you'll find even more content on my YouTube channel. So I just want to thank you. Thanks for listening to me about this idea, and I look forward to talking to you in detail more about the idea of a unified API design method.